Let's take a look at our last section for the semester 8.3, the geometric sequence and series. Geometric sequence is a sequence in which each term after the first is obtained by multiplying the preceding term by a fixed non-zero real number called the common ratio. The sequence 1, 2, 4, 8, 16 is a geometric sequence in which the first term is 1 and the common ratio is 2. As you can see, 1 times 2 is 2, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, so on and so forth. If the common ratio of a geometric sequence is r, then by the definition of the geometric sequence, r is equal to a sub n plus 1 divided by a sub n. So you just divide any two preceding terms for every positive integer n. Therefore, we will find the common ratio by choosing any term after the first and dividing it by the preceding term. Easy just to take the second divided by the first. In a geometric sequence with first term a sub 1 and the common ratio r, the nth term a sub n is given by the following. A sub n is equal to a sub 1 times r to the n minus 1 power. So if we had an example here, it says suppose an employee agreed to work for 1 cent the first day, 2 cents the second day, 4 cents the third day, 8 cents the fourth day, and so on and so on and so forth, with wages doubling each day. How much is earned on day 30? So this is our geometric sequence. Our first term is going to be a sub 1, which is 0.01, 1 penny, where r is doubling that. So therefore, our a sub n is going to be 0.01 times 2 to the 30 minus 1 power, or we'll call it 29 when we enter it into the calculator. And this employee is going to make $5,368,709.12 on the end of the month. Wouldn't you like to be able to talk your boss into that kind of a salary? All right, number 2, find a sub 8 and a sub n for the geometric sequence 4, 12, 36, 108. Well, just by looking at it, I can see the first term is a sub 1, and mentally I'm doing 12 divided by 4, so r is 3. So I might as well go ahead and find a sub n right away. Just plug in the values. A sub n is equal to 4 the first term times 3 to the n minus 1 power. Then find a sub 8. We'll put 8 in for the n's. We have 4 times 3 to the 7th power, 8,748. So as you can see with these geometric sequences, their terms get big really fast because it's technically an exponential function. Our example 3, find r and a sub 1 for the geometric sequence with the third term 20 and the sixth term 160. So first we're going to find our r. So to find that r, I'm identifying a sub 3, the third term, to be 20 and a sub 6 to be 160. So visualizing what's taking place here, if the third term, a sub 3, is 20, to get to the fourth, the fifth, to the sixth, you have to multiply 3 r's to the 20 to get to 180. So that's an equation. We'll say 20 times r to the third is equal to 160. We'll solve for r. We'll divide over the 20. We get an 8. Take the cube root of both sides. R is equal to 2. And now we have to go find a sub 1. Well, again, a sub 1 times 2 to the second power, because I want to get to the third term. That's 2 r's that I have to multiply by to get to 20. Well, that's 4. Divide both sides by 4. A sub 1 is 5. So I found my 2 requirements. Example 4, a population of fruit flies is growing in such a way that each generation is 1.5 times as large as the last generation. Suppose there are 100 insects in the first generation. We'll call that a sub 1. How many would there be in the fourth generation, a sub 4? Well, by telling us that each generation is 1.5 times larger, that's your r. A sub 1 is the 100. So we'll go right to our formula. A sub 4 is equal to the first term times 1.5 to the third power. That's 4 minus 1. And we're going to get 337.5. Well, we can't have half an insect, so we'll round it up to 338.